Yeah, hello.
Hi Manoj,
Yeah, hi, Nancy. How are you?
I'm good. How are you?
Yeah, good here.
Sorry, there was a delay because it was raining here, so I couldn't
Yeah,
reach home on time.
yeah,
That's why.
no problem, no problem.
Yeah,
Okay. So, are you okay now?
yeah, I'm fine. Ready.
Okay. 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 So, before we start with the session, I just want to know about your knowledge in programming. I think we didn't discuss about this detail in the last demo session we had.
Yeah.
So why don't you just tell me, what you know about programming and what you learned? So you are basically a commerce background student, right?
Yes, Manoj.
Okay. So what is your, when did you start learning computer science? I mean, anything like a programming or
No,
something
programming
like
is a zero knowledge actually.
that? Okay.
So because
So, yeah, go on.
more I work into Excel, so more of automation is required for few of
Okay.
the works which I do. So that's when I thought I'll learn uh, VBA or Python, anything which is going to help me in getting the data gets scrapping.
Okay. So you already took a course in VBA, I'm right.
Oh, yes, it's
Okay.
just a
Yeah.
basics which I've taken.
Okay.
But
But
comparatively, when I did a study about VBA and Python, I felt Python is more easy in writing the language, the code.
yes.
So that's when we thought, okay, I want to try Python actually.
Okay. That's good actually. Okay.
Somewhere down the
Uh,
line, if I have to do something on my own also, if this is going to be helpful, it will be much better. That's why.
yeah, definitely. Because I've seen people who actually change their career once. I mean, after learning some programming languages. So Python will be a very good tool for that, for understanding things. Okay, so during your college, I mean courses in your undergraduation or post graduation, I, to my knowledge, some of this commerce kind of courses like BBM or kind of course, they have an additional paper called CA. The computer application CA paper.
Okay.
So, did you come through anything like that? Did they teach anything related to computer science or any basics?
No, Manoj, because I had taken BCom and I had passed out in 2007 actually. So
Okay.
it's been very long back, and I think only these days they have actually added all these papers, which is very useful to work, right? So they have added these days, but 2007 batch, I don't remember we having that paper actually.
Okay, 2007.
Yeah, passed out.
When I passed out my undergraduation in 2007.
Okay.
So, just for an information, from which city you are? I just want to know your mother tongue, something like that.
I'm from Bangalore and Tamil.
Tamil. Okay,
Yeah.
that's nice. Okay. Uh, mm, okay, let's just start with little basic. I mean, I believe that if I give you some introduction about how things work in computers, and more like we start from the scratch so that you can have some strong understanding of how things will happen when you program. Okay, so let me just share my screen.
Okay.
Hold Okay, is my screen visible, Nancy?
Yes, Manoj.
Okay. Okay. So these are the things we're gonna today. Some introduction from, from okay, just programming. Then and we'll discuss about scripts and discuss about paradigms. Any time left today, we'll also carry on with the installation process.
Yeah.
So have you ever tried programming Python by learning something from the online or watching into any YouTube videos, something like that?
I've actually watched it, but never tried practically. Watched YouTube videos.
Okay. I've just used something like a camel case here. This is what we call camel case in computer science. I mean, I started this setup word with lowercase s and used uppercase p. Okay, so something we'll be using more in programming. Okay, okay. So tell me if you know something about how computer works. I mean, from a general perspective, uh, according to your observation. So yeah. Hello.
Yes, Manoj, tell me.
Hello.
Basically, some hello.
Yeah. Can you hear me?
Yeah, yeah, I can hear you.
Yeah.
Little, your voice is
Yeah.
breaking.
Just go on, Nancy. Okay. Yeah. Just tell me what you know about computers and how things happen when you use a software, something like that. Just a little thing.
Basically, some what do you call some applications will be there right within. So through that we can work. I don't know how to explain actually.
Okay. No problem. Just
Yeah.
let me go with that. Okay. So basically, computers are uh,
Anuj, can your
something.
voice be a little bit louder?
Yeah. Actually, I'm holding a headset near to my mouth. Uh,
Okay.
yeah. Am
Okay.
I audible now?
Yeah.
Yeah. Actually, computers are basically dumb machines. It has all the resources for processing high calculations and holding high amount of memories and all kind of features in it. But it's basically dumb. It doesn't know what to do on its own. So somebody has to give some instruction to do the computer what to do. So that is where we use languages. I mean, programming languages. So programming languages are kind of a medium where we'll frame instructions and give that instructions to the computer to do some job. Okay. um, But thing is, computer can't understand what we speak. So computer has its own language. And one more thing, just tell me if, just let me know if any voice problem, I mean, any breaking up kind of thing.
Sure.
Okay.
Yeah, yeah, sure.
Actually, computers don't understand what we speak. The computer has
Okay.
its own language that I think it's all in zeros and ones. So that is how the hardware electronic signals are moved in and around in the chips and everything. So computers actually performs with zeros and ones. So initially, during the development of computers, people used to program. I mean, give instructions using programming using this uh, zeros and ones. So in other words, it is also called as machine language or machine understandable language. So it was really very painful process. So they created something called an assembly language, which is considered as a higher level language comparing to the computer's machine language, the zeros and ones. So this higher level language, assembly language, is something related to our humans' natural languages, like what we speak in English. So if you want to say a child, go there, like you'll say go, or move your hand, we'll say move, something like that. So this assembly language actually had mnemonic codes, something like suppose if they need to add something. Let me just um, suppose we want to add something. They will give like add 5 space 6. So suppose for division, or so assembly languages look something like this, but it is not the actual representation. It looks much more complex than this. I just want to give you an idea. Okay. So these assembly language is the first form of human interaction. I mean, with their natural language to a computer. This actually creates a bridge between human and the computer understandable language. But you can ask, if computer can't understand natural languages, how can the computer can actually process these uh, instructions like add, divide, and multiply kind of things. So for that, they developed something called an translator. So that translator is called assembler in this case of assembly language. So what that translator do is, second, let's just think. Okay, so the kind of assembler is a kind of translator which actually takes code from this assembly language and converts into machine executable zeros and ones. This is what happens. Okay, so here, when comparing to the machine language, the assembly language is considered as a higher language. But even though it is considered as a higher language, it is nowhere near to what we have today, like higher level languages like Python and C, C++, Java. The reason for the development of those high-level languages is because assembly languages is not easy as we think. For someone to code any instruction in this assembly language, the programmer should have a very good understanding of how the computer's architecture really works, and how everything is laid out in electronic level inside the computer CPU or computer board, everything. So that was a really very tough task for everyone to do. So they developed something called a high level language. Because of the development of high level language, more people uh, learn these languages, and so far they've created millions of applications what we have today in this world. So this is actually assembly thing. So we just talk about the some higher level languages. So higher level languages functions the same way as each language. Yeah. We have a high level language. We just draw two box here because later I need to explain another type of translation. Languages. So these high-level languages have something, a translator, some translator like what we saw in assembly language. So assembly language had something called an assembler, which is a translator, which translated the assembly code into a mission executable zeros and ones. So similar to that, for every higher-level languages, we have a translator here. So these translator actually converts these higher level languages to mission executable code. So these higher level languages are much user friendly than any assembly languages out there in the field. So these are more constructed with the English, the normal English grammatical structures. So anyone can easily understand what actually happens inside the language. Only thing which differentiates it from writing some instruction in regular language is it involves something called the syntaxes and procedures kind of thing. Syntaxes are nothing but how to uh, put certain things in the program, more like rules to lay things in the code. So, so these high-level languages can be translated using two types of translators. The two types are one is actually using a compilation process. One is a compilation process. Another one is called interpretation process. So the translator which uses so the translator which uses compilation process is called as compiler, and the translator which uses interpreter, I mean interpretation process to translate the code called interpreter. So these both will actually translate to mission executable code, but there is a difference in the translation process itself into mission code. Okay, so we have two types of translators. One is a compiler, and which uses a compilation process. Another one is an interpreter, which uses interpretation process. So what is the difference between this compilation process and interpretation process? So compilation process will actually uh, convert these. Suppose this is a code file. Let's take this is some programming language, and for example, we'll take C or C++, something like that, which is a compiled language actually in nature. So this language when we write code in this language and when we put to execution, we had two steps here. First, we'll actually compile the code. So when we compile this code, what happens is this compiler will actually convert this entire code, I mean, entire file in one go to mission code. But that is not the case with interpreter. What interpreter does is it actually compiles each and every line. For example, if we have codes here, this is a code file, and what happens is the compiler will actually takes the entire file in one go and it converts into machine code before it gets executed in the computer. But in case of interpreter, it takes each and every line at once and it converts into, I mean, it interprets, that is, it translates into machine code and transfers it to the computer to run. Like that, once the first step is completed, it continues with the second line of code, then the third, then fourth, fifth. And if there is any error occurs in between these conversion, it just stops the conversion process in from the high-level language to mission code, and it just notify the programmer through the editor or whatever it is. It is called, actually they'll say, like a uh, stack trace or something like that. So we look into it in future lectures. So through that it will notify the errors so that we can, once we fix the error, it will continue with the further compilation, I mean interpretation process. But in compilation it is not the case. In compilation it will compile the entire code at once. If there is any error while compiling the entire code, it will not move further. So we have to fix everything before we put the code into compilation. uh, Advantages, or the compilation process is actually much more faster in execution when compared to interpreter. That is why C and C++ kind of languages are much faster than most of the languages we have today. That is why like contest programming in things, people use mostly C++ kind of languages. Okay. So far, any doubt in this?
No, Manish. Understood.
Okay. Okay. Let's just start with, just a moment.
Yeah, sure.
So now we'll actually see about scripts. So scripts are nothing but anything different from programming languages. So scripts are kind of programming language. The only difference is um, programming languages. The scripts or scripting languages or a kind of programming languages, but the difference is scripts are interpreted, unlike full-fledged programming languages like C or C++, which we discussed earlier, which gets compiled to translate the high-level code to the mission executable machine language. But in case of scripts, the code is actually converted using
Hello?
Hello.
Yes, Manoj.
Yeah, I'm sorry. Actually, there was some connectivity issues here.
Okay, sure.
Yeah, let me just share my screen again. Is my screen visible now?
Yes, Manoj.
Okay. So let me repeat the thing one more time.
Yes.
So all scripting, I mean scripting languages or programming languages, and scripting languages are basically languages where instructions are written for a runtime environment. I mean to put into execution. They don't actually get compiled. They actually get interpreted by the interpreter and translated into the machine executable code. Okay.
Okay.
So it also the scripting languages also acts as something called like a glue code, which actually connects two functions or two programming um, functionalities, and it is quite simple. I mean, it is quite easy when comparing to other programming languages like C, C++, or Java. In case of learning and developing things in much faster way. So
Okay.
Python is actually considered in one way. Python is considered as a scripting language, and we have some examples of scripting languages like JavaScript and like Bash and Ruby kind of thing.
Manoj, do you have any soft PDF documents of these notes, basically the meanings or definitions for whatever you
No,
explained?
no, actually, I don't have anything in my hand. Maybe I think you can contact the institute. Maybe they'll be able to provide you with.
Okay.
Okay.
Yeah, yeah, sure.
Because I know because since being a beginner, it would be better if we have something to refer while you start coding.
Okay, sure.
Okay. So what are the types of scripting languages? So we have like two types of scripting languages basically. Uh, those are one is client-side scripting, and the other one is server-side scripting. So mostly these scripting languages, or you would have heard they're used in web applications for functionalities like getting data. For example, we use HTML and CSS to design web applications. I mean, at the front end of a web application. for all the visual purposes and put display things on the screen kind of thing. For example, let's take a form filling application. We have everything like a text box and buttons and controls, everything. Let's take an e-commerce application. You have all the fields, uh, uh, which is visually you can actually interact with it. But all these fields and all these objects on the screen, what you see on the e-commerce site is all designed using HTML and CSS. But when you actually interact with that page, when you make some action, things like buying a product or adding a product to a cart or entering some information or registering yourself with the application, it actually, the HTML and CSS can't actually take your data and pass it to processing in the backend. So we need scripting in that area. So we use simple JavaScript to actually fetch those data from that text boxes or whatever buttons or controls you press, and carry that data to the backend or any other process which actually process take this value and process for the further process. Uh, so it just passes. So for these kind of functions, we use scripting, and also to automate things. I mean, things which require a repeated, task uh, like what you used to do in Excel, right? Like
Yeah.
setting up macros kind of thing. We
Okay.
need scripting kind of languages. And we'll also use scripting in standalone applications like any uh, uh, Windows applications which does not require any network to function. And we use scripting in gaming applications and any multimedia kind of applications. And scripting languages are used to create plugins and extensions for different programs. Plugins and extensions are nothing but a small piece of software which we will use to increase or add some additional functionality to some existing software what we use already. Uh, for example, you're using Python programming. Uh, you need something like you want to process Excel files using this Python programming. So you'll add a library, something like pandas, something like a library. So these libraries are nothing but it's all Python written codes, which is already written by some experts out there, and it is widely used. So only thing is it's more like a plug and play. You just need to import those libraries and implement in your program. It's more like taking different ingredients and putting into one main dish and creating it into one whole complete dish.
Okay.
Okay. So the two types of scriptings are one is client-side scripting and server-side scripting. So what I told so far is client-side scripting. I mean, on the web application example, and we have something called a server-side scripting. The reason for using server-side scripting is in most of the cases, people who design the web application or any web software, they don't want their source or scripting code to get exposed. So they use some scripting process or some data processing behind the scene of what you see in the web application. And we have a very widely used scripting language called JavaScript. And people might think JavaScript is only used to program the front end of any application. But today we have something called Node.js, which we can actually use at the back end to do some server-side scripting here. Okay.
Okay.
So any doubt so far?
No.
Yeah. And some backend scripting languages, as I told, Node.js, and another one is ASP. We have ASP.NET, something related to that. I mean, since you worked in VBA, you would have heard about this term, ASP.NET. Uh,
AHPs.
ASP. Okay.
Okay.
Okay, and there is also another scripting thing called PHP, and there are some front-end scripting languages we have, like CSS and the JavaScript, what I told previously. And but these scripting languages have some advantages and disadvantages too. When you look into its simplicity, it is much more simpler than coding a regular programming language. For example, if you want to do something in a language like C or C++, you have to specify everything. And suppose if you're coding a data for functioning something for a multiplication process, or to create an action for a doll or a robot something, you have to specify every detail, like what type of input it takes. For example, if for a multiplication program, if we take two values, it has to specify, for example, in C. Let's say, suppose if you're using a C language, if you want to multiply two numbers, you're creating a function. You're creating a function with taking two variables, and this prints. We'll create another variable called result, which actually calculates the variable 1 and variable 2, variable 2, and it just prints the result. So for this line of code is not enough. I mean, this is just a function which actually calculates the two numbers and prints the result. So before we executing this function, we have to actually specify every detail of the variable we are passing inside the function. For example, we have the variable 1. If you are passing number, it's a simple number. If it is not any decimal number, we just need to specify it as integer. And variable 2 is of 2 integer. Suppose if you are passing two decimal numbers, you got to specify its data type as something like float, or if you want to do something other than any multiplication process, if you want to just take some kind of string, suppose let's say hello. This is a hello variable. What happens is we need to specify this hello as something like a string or free. So when we call this function in C, we'll actually pass these variables we declared over the function. I mean, the float variable 1, float variable 2, and string variable 3. We'll pass it to this function so that it will know what type of data it is dealing with. But that is not the case with a dynamically typed scripting languages, something like Python. The same code can be written in Python, as you don't have to declare any or define any variables prior to the function. This is just for an example I'm giving this.
Okay.
We'll see in Python we actually do something like, okay, you don't even have a brackets here. It just prints for 1, 2, or 2. So this is all the code we need to do the same function which we used So this is actually what we do in C. But don't take it for real. Actually, this code I coded is not actually the C program syntax. Just want to give you an example.
Okay.
Okay. So, but this is actually an actual Python code.
Okay.
So how many codes were there in C? 1, 2, 3, 4, 5, 6 lines of code and two extra brackets, which we actually coded using just 2 lines of code in Python. The reason why we code like this is called dynamic typing. What happens is in programming language like C, we have to specify everything. For example, you are sending a letter to your friend. Uh, and what you'll do is you'll specify each and every detail of his or her excuse me house address, which state they belong to, which city, which street, and what's the door number, everything, and you will just post it. Some postman will pick it and he'll search for the house based on the address given in the letter, and he'll deliver the address. So that is how the C program actually functions. But what happens in Python is if Python are a postman, all you need to do is just write the letter and just write the name of your friend and just put it in an envelope and just give it to the postman. He'll find out where to deliver the address dynamically based on what information or what kind of situation. Okay, can you? Does it make any sense?
Yes, Manoj.
Okay.
DEF refers to define, is it? Here?
Yeah, DEF is actually we use in Python. So that is a keyword. Let me show you one in the real Python. Just hold on. I've just hit the Python code editor. So this is a code editor for Python. What I use, it's called a Sublime Text. You can use anything you want. There are so many code editors out there. But since you're learning, I would recommend you to download something called PyCharm that we do in following lectures during the installation process.
Yeah.
The Sublime Text is actually it's much faster than PyCharm, but a few things are not supported by Sublime Text, like getting input from the user in while running the program, something like that. Um, so it will be literally something. Excuse me once again. Yeah. So def is actually defining. So define a function just for the sake of showing. I mean, explanation. This function name you can specify anything you want. Suppose if you want, you can do like this, and you can pass a variable, and you can do something like this. This in a quotation. Like, paste. Okay. So we actually created a function here. So I'm not teaching how to create a function here. I just want to show you some example of Python code. That's it. Okay.
Okay.
Since you asked what is a def keyword,
Yeah.
yeah, before we start with the function, we need to learn a few basic things like how other variables and a lot of basic things we need to learn. Only then you can actually understand what goes inside this execution process.
Sure.
Okay. So once we define the function, we need to call it to actually put the program to oh, execution. So what we'll do is we will call Nancy, and we need to So to call a function, we need to actually add a bracket to it. Since you passed a variable is something like a temporary keyword or something. It's defined by you, uh, which holds a value, dynamic value. I mean, you can pass any value. So, for example, if you give Nancy, it actually prints Nancy. So please welcome Nancy. It gets printed at the bottom. Can you see here?
Yeah.
So if we change something else, we want to give something like G, prints G. So it is a variable. You just take anything you enter and just process inside the function and prints it. That's it. So this is a basic form of function definition when we're defining a function. And when you learn more code, you will actually get things done by coding this function in much more complex way by adding a lot of conditions like if else kind of thing and setting loops and branching kind of stuff. So after mostly like 3 or 4 weeks, you will be able to predict the output from a rich coded function.
Okay.
If I show you some function with 2 or 3 if statement and 1 or 2 while loops or for loops and if, some kind of branching statements inside, you can easily take a look at the function and predict what output it actually produces. Okay. So these are the scripting languages. So
Okay.
in scripting languages, we have some pros and cons of scripting languages, not all flowers or roses here. So the advantages of scripting languages here is it doesn't require any compiler to compile the language, and it is easy to transfer between operating system. It is not one mission dependent. Like there are some languages which runs only on certain platforms. For example, let's take Visual Basic. Visual Basic is actually designed to run on Microsoft platform. That is why most of the .NET and Visual Basic related applications are developed in Windows application. I mean, with computers with Windows operating system. But it doesn't mean that they can't use Visual Basic or any Visual Basic related programming languages in computers, which has other operating systems like Linux or Mac. But they use some intermediate tool to actually get things compiled in this thing. Okay, so that is where actually programming languages like Java and Python actually shines. They are actually in mission independent languages. They don't actually depend on one particular operating system. Um, there is a reason for that. Um, I'll explain to you while explaining how Python actually gets compiled in real time. So coming back to the scripting languages advantages, so it doesn't need any compiler to compile. So because it is interpreted and it is easy to transfer between operating system, and it actually helps to do more processing or adds more processing power for web pages or any gaming applications, as I discussed earlier. And some disadvantages of scripting languages are mm, they actually kind of little slow when compared to programming languages. And that is actually mostly people see as a fault in a scripting language. So, any doubts so far, Nancy?
No, Manoj.
So, on my task, actually, what type of language is Python? Is it a scripting language or a programming language. But when you check in Google or if you ask any experts, I mean, most of them would say actually Python is a scripting language. But technically, it is scripting language, but also it's an imperative development language also, because today we have like more than nearly 1.5 lakhs of libraries, which is developed using Python languages, which supports a lot of operations in real world systems. That's why Python is actually adopted by a lot of high-end software development processes like artificial intelligence and machine learning kind of stuffs there. Okay. So previously we saw what is compilation and what is interpretation, and some examples of this compiled programs or C, C++, Java. I think I specified that, and some examples of interpreted languages, or one of the examples is Python, but mostly you'll hear like Python is an interpreted language, but in reality Python is both compiled and interpreted. So let me just give you an example why Python is called as interpreted language, not compiled, and why technically it is also both compiled and interpreted. For example, let's just take this is a Python code.
Actually, your screen is in the left, little bit, actually, left side. Where
So I'm sorry.
the screen is actually on the left side. I think something is hiding there, hidden actually.
Any problem?
The
Hello.
screen, the screen is not fully visible actually. It's somewhere hidden on the left side. It's not in the center. Yeah, now it's fine.
Yeah, I don't know. Maybe.
Yeah.
Okay. I actually minimized it and dragged it to the center. I think it's a problem with the blue jeans thing. I shared my whole screen actually.
Okay.
Okay. So Python files are saved with an extension called, for example, we'll create a program with the name sample, and we need to give an extension called py. Okay. So let's take this is a Python file. So usually what happens if we have a high level written language, so you, you can recall what is high level language, right? So high level languages are nothing but what we program in the computer, like C or C++ or Python, to actually instruct the computer to get things done. Okay, so any high-level languages we put into execution, it will get translated in something called translator, depending upon what type of language it is, whether it is compiled or interpreted. It will have its translator, which is compiler or interpreter. Uh, for example, C and C++, which will have compiler, and program which are interpreted like scripts, and Python and JavaScript kind of thing, we'll have a translator called interpreter. So it will interpret the language and convert into machine executable code. So in this case of Python, actually generally people will tell that this language is interpreted language, but I'll show you why it is both compiled and interpreted. I'm using this MS Paint after a long time. That is why actually it's taking too much time to work. Let's take this as interpreter. Since Python is called as interpreted language, we'll take this as an interpreter. And we'll have this machine executes machine language. So this is what usually happens in other interpreted language. It takes the code, I mean, whatever we code. For example, we just coded
Yeah.
something, we coded a function to print your name with a welcome function. So what happens is, yeah, this code is here. So this code, I saved it as rough1.py.
Yeah.
So this, excuse me, so this rough1.py will, so this rough one, I just named it a sample.py here. No, don't bother that. Sorry. And it will just get interpreted by an interpreter, which is a kind of translator, and get executed in the machine as a machine language. But thing is, the reality is, we have something called we'll have a compiler in this between this interpreter and actual Python code. And this compilation process, what happens is when we code something in a compiled language like C or C++, suppose assume that this def call Nancy function is coded in C or Java. Okay, so what we will do is uh, once we written the code, when we put into execution, before execution, we'll actually compile the code by, for example, if this is a Java programming language, we'll do something like Java C space. Um, we'll have a class for this thing, or I'll just use the file's name OUGH rough1.java. What happens is this thing will get compiled and it produces a machine language output which will further get processed by the computer to produce output on the screen or whatever process it intends to do. Okay, so in Python we don't have to actually separately run this thing. In Java or C++, we have to run this compilation process separately after coding, and we have to run the code separately.
But in
We have
Python, it's not required. That's what you're telling,
Yeah,
right?
yeah. In Python, we actually have only one process. All we need to do is, yeah, just if it is in a command prompt or any terminal, I would use this command to run a Python code. By running this code, I'll use rough1.py to compile this code. If I were doing this same code in command prompt or any terminal, since I have a code editor, I don't actually need. I don't need to run any execution command. The code editor will takes care of this automatically. All I need to do is use some shortcut keys. Here I'm using, I'll use Control S to save before making any changes, and I'll use Control B, which actually runs the program. And you see it's getting executed. I mean, at the bottom of the editor.
Yes, the immediate window, right?
Yeah. Okay. So here actually what happens is in languages like Java or C, after creating this file, this main code file, let's say this main code file, we need to separately compile this file
In
and
Java
for
and CS.
and C++ kind of languages.
Okay.
I mean, any languages which uses the compilation process for the translation. And we use this compilation process separately. We just okay. C represents compiler.
Okay.
So after compiling, separately we need to run the program to continue with the further process. But in Python, when you run the code by giving Python space the file name or doing something like what I did in this editor, pressing the shortcut key, and if you run the program, what happens is this compilation process will be taken care by the Python itself. So it is automatically gets compiled by the Python itself at the backend. So that is why it is not mentioned in most of the articles or any tutorials. that Python is both compiled and interpreter. Only something which concentrates any books or articles which gets deep into this Python execution process will tell you that this is both compiled and interpreted. Okay, so all we know is this program is getting interpreted. So what happens is automatically this file will get compiled into uh, something called a bytecode file here. So
What is it?
bytecode. Let me just give you a. Oh, let me draw it here. Let's take this file. This as a file. So what does this bytecode means?
The space, is it?
Yeah. So you can
No.
see the paint window completely, right?
Sorry?
Uh, you can see my paint window is completely visible,
Paint
right?
window I can see fully, yeah.
Yeah. And what about the code editor here?
No, it's a little bit hidden.
Okay, let me
Yeah.
reduce the size. So it's visible now, right?
Yes, yes.
Okay. So here actually, once we run the Python file like this, whenever I run this code, this line from 1 to 5 will actually gets compiled behind the scene by Python, and that compilation process will actually produces something called a bytecode. So bytecode is nothing but it is a small kind of translation which actually translate this file. I mean this file from number 1 to line
Into
number
file.
5 to to actually into some kind of instructions which is understandable by the interpreter. Okay,
Okay.
so the interpreter has certain kind of certain set of rules. Only which follows that rules will get executed or get translated in the interpreter. So this compiler takes care of that process and it converts to that interpreted compactable file. So that file is called this bytecode. Okay.
Okay.
Okay. And this interpreter again, what in interpret what happens is this bytecode will actually gets translated into the zeros and ones. So let me show you an example of this bytecode here. So we have written this def call Nancy. So the fifth line is actually I'm calling this function. Nothing will happen if I delete this. Just let me run this. It shows no output, but it just tells me that there is no error. The program actually executed successfully. If there was any error, it would have notified me here. Let me show how error get notified. Let me just uh, create some kind of indentation error. See, one more thing actually, in other languages they use brackets to hold a scope for function or any class or something like that. But in Python actually they don't use any bracket. It is all indentation, spaces. So whenever we code Python language, these spaces, even if you leave one extra space, it creates a problem. So spaces are very sensitive here. So this is actually one tab. In line number 2, I highlighted a small portion of the code, and this portion is actually one tab space. So this tells the compiler that this line number 2 is actually inside this function definition code called def call Nancy. So what happens is this thing will get executed inside this def function. So I'm just going
Space,
to.
that was, is it?
I'm sorry.
The space before print. That's
Yes, yes, yeah. So whatever you create, for example, if you create a class, I think when I speak about class and definitions, can you able to catch up with this, or will you just leave it for for future
no,
classes?
no,
Can
Manoj,
you
I will not.
can, can you able to catch up the classes and definitions?
No.
Okay. Okay, let me just leave that. Never mind. Okay, so if you're doing some procedure here, for example, do some work. Mm, I'm just Nancy is just going to code a robot here. Okay, you're just telling this robot. Let's name this robot. Wait, name this robot as whatever you want. Like Dave is the name of the robot. Okay, don't take this line as a code. Let me just comment this line so that you don't create any problem. Okay, suppose if you want to, that computer is a dumb machine. It only performs what you instruct. I mean, what you ask the computer to do, right? So when you create a robot in a program programmatically, it won't do anything. It just sits there and do nothing. So to actually make the robot to do something, you actually programmatically give some instruction. So what you will do is, for example, you will create a unit of code which actually tells the robot to actually move its right arm. For example, you actually create a function. Uh, okay, let's not discuss about functions and methods. Just assume this is a piece of code which actually tells the robot what to do. So what happens here is they will move its right arm. Like that, if we create another piece of code, left arm. And if we just want to tell him to move from one spot to another spot, we just tell him, for example, let's say move, move, and we can set how much distance he should cover when we ask him to move at once. For example, when we ask him to move, I mean, when we suppose we have a button, if you press the button to tell that Dave, please move, then the Dave should actually take some distance into consideration, and he should actually move only. For example, if we set a parameter like Dave should only move 1 feet, he should only move 1 feet, not anything. I mean, more than 1 feet or whatever we specify. So we'll say they will move here. So we'll do something like we'll set uh, distance as a variable. Okay, we'll say like 1 feet or 1 inch is enough. Okay, so these are all some pieces of code which we will actually uh, code to a robot or any program. So whenever we call this function by any modes, like maybe we can call using creating a function call. There is a term used in programming, just like what we did with the def call Nancy function.
Yeah.
You remember that we actually used this name, right, to actually run this
All.
program. We called call Nancy and we used a bracket here, and we passed your name here. So this is a kind of calling this function for the execution process. Okay. So similar to that, there are so many ways of calling functions. So it can be directly calling the function like what we did, or it could be some button press, or it could be like from another function. Suppose we have move, and this move actually functions based on what operation actually did previously. For example, if it moved right direction and it cannot continue further, there is a block or anything, then what happens is it takes the output of this function and it just moves some other left or any other direction other than proceeding with right. Is it confusing?
Yeah, a little bit actually.
Okay. So this is basically to explain there are scope for functions. This is how C or C++ function is written. So we create a piece of code, and whenever we say something, whenever we want to do something inside that code, whenever we call this code, in programming, everything is based on English grammar. So functions are actually named with which contains strong verb in it, based on what actions it actually performs. And suppose, yeah, um, if you want to make this robot to move, right, you're gonna do some code inside this brackets. Uh, so what happens is when the compiler or any translator which reads this line, it knows that this piece of code, line number 6, is actually inside this function. So whenever you call this right arm function, this will get executed and it will actually make the robot to move its right arm. So the main actually the why I actually started to explain this is just to say this space indentation problem. So here in
You
other
guys have
languages,
less than one space, right?
I'm sorry.
In for function line number 5, not line 5, line 6, you have just uh, given one space.
Yeah, actually, here there is no problem. I mean, most of the languages which have this bracket functionalities with it. For example, in Java, you use brackets to define the same. Let me just write the same function. To define the same call Nancy function, in Java, what you'll do is um, you'll say an accessibility variable, and please okay, don't want any confusion, so I just call Nancy, same variable. Let me put a bracket here. So whatever code we need to execute, it goes here. Okay. So in most of the languages which has this bracket functionality, it won't actually bother in most cases. Even if there's any space problem, it will get executed. But it is this condition is actually very strict with Python, because Python doesn't have any bracket to tell the compiler that this line number 2 is actually inside the line number 1. I mean, this line number 2 actually belongs to this line number 1. Okay. So if there is no space here, what happens is Python thinks that this is another line of code, which is to print something. And what it takes is, it takes that we defined a function here, but I mean, we created a function here, but we didn't actually define
Execute.
anything. Yeah, not execution. We didn't actually complete the function. Let me just run and show you. See, expected and intended indentation block. Okay, just because we have a code here, it says that. Sorry, let me just remove that. And so I've just created a function name here. Okay, and I didn't define what the function has to do when it is executed. So I just created def called Nancy. Let me I just saved it. I just run it. See, unexpected end of file while parsing. So what it says is that this should not be the end of this line of code. So we need to complete this line actually. Okay. So what we do is we'll we just print the same name, and now we'll run and see how it actually produces the indentation error. Since Python doesn't have this bracket functionality in its code, we had to be very we had to follow the rules strictly. I mean, the indentation rules. I mean, spacing is very important. So here it says that expected and indentation blocks. So I'm going to just give one tab of space here. Now it actually,
That's
uh,
it. Okay.
yeah, one tab. Now it actually tells Python that this line number 2 actually belongs to line number 1. And line number 1, since we use the def keyword, Python understands that this is a function. Uh, so this should be treated as the whole code which comes under this line number 1 with the one tab space will be treated as part of this function, line number 1. So whenever you call Nancy, this will get printed. So I'm not passing any variable. Now see what error it produces. It says that the call Nancy missing one required positional argument. It says that we didn't pass any argument here. So whatever we pass in here, it is called as argument.
Okay.
So we need to do something because it is expecting something here.
Okay.
Only when we pass something in this bracket, in this var variable, or you can give whatever you want. It doesn't have to be one type of word. Suppose if you want like a b c d, you can give a b c d, but make sure this thing matches at the processing point. Okay, now actually what it says is now the line number 2 is actually expecting this abcd variable. Let's assume this as a bag. Okay, this abcd as a bag. So this
Okay.
abcd bag is actually carrying something when you're executing a function. And what happens is the line number 2 will actually opens a bag and takes whatever in the bag and produces the result or process or whatever it is. So what happens here is the line number 2 is actually expecting a bag or a product, whatever it is.
Okay.
Since we didn't provide anything here, any product inside this call Nancy function, what happened, what error it's showing is it required one positional argument. I mean, it's missing one positional argument here. So what we do now is we'll just give that product here, product or bag, whatever it is expecting. We can give anything. We can give um, Jeremy. Okay, but make sure that we give it inside a quotation because it is all strings. When we give something without this quotation marks, it will treat it as some kind of keyword. And keywords are nothing but which are unique to any programming languages. For example, Python has a set of keywords. And for example, this print is a keyword and this def is a keyword. It means something. When we use def, it means define something. I mean, define a function. We use it. Print keyword, it means it calls a print function, something like that. So this is all user-defined types, but these are all predefined keywords. Every language has its own set of keywords. So we should be very careful while programming, I mean, while using these keywords in any programming language.
Manoj, can you
So
run
that is the
this code?
only reason we act. I'm sorry,
Can you just run this code now?
you want, yeah,
Isn't, yeah, I want to see something. Okay.
okay, now it's actually prints. So if I don't put this in the quotation, what happens here is throws an error. See, Jeremy is not defined. If you are using some keyword here, the keyword has to be defined. I can define something here. Maybe if you want, I can
We
define.
have
Let's
actually
say,
defined.
no, we didn't define the Jeremy here. So Jeremy is actually something, a product we are giving it. Okay. So we need to wrap it up in something like a quotation, and we need to put it here. This is a bag actually. Okay, so it will confuse you now because we haven't started anything with the programming. This is only for
Okay.
the explanation purpose. So you don't want to
Okay.
don't get confused with this. Okay, so we'll see a few basic things before we start with this function creation.
Okay.
So you'll understand. Okay, this is just to show you some example how the scopes and things works. Okay, so actually we came here by uh, middle of explaining this bytecode, right? I
Yeah.
I actually open this editor to show you what bytecode actually looks.
Okay.
Okay, so this def function. So when I call Nancy, this will actually print. Let me ask. It actually prints Nancy, and as I told before, when we run this program, automatically it gets compiled and it will translate it into bytecode, right?
Yes.
So let me show you what the bytecode of this set
Code.
of lines, I mean code lines, it looks like. And let me just import. Uh, I'm actually importing something called library, and that library is called a dis. Is a short form for disassembler. Okay, we'll learn about the libraries and imports when we touch something inheritance kind of topics. Okay, okay. Now actually, there's dot online. See, yeah. Can you see this? This is nothing but same. These lines are actually performing the same action. I mean, the actions are similar to what we coded in the upper section of the editor. Can you see, you can see the code, right? The
Yes,
bottom of
yes.
the editor. This is
Yes.
actually called bytecode. So what happens is whenever we compile this Python code, I mean, we won't compile manually. Whenever we run this code, this compiler, I mean, this automatic compiler will actually compiles this and converts this code. I mean, converts this line number one to, excuse me, converts this line number one to line number eight. I mean, line number six. Line number one to line number six into a bytecode which looks like this. Okay,
I think this
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 bytecode.
screen which is hiding it. Yeah, now I can see.
Let me just check my. Just hold on. Let me check if I can actually control the screen sharing. So now you can actually see my screen, right?
Yes, yes.
Hello.
Yes, Manoj. Hello?
Okay.
Yeah.
So yeah, yeah. Can you hear me?
Yes, Manoj.
Yes. What the? Okay. This is a special set. Uh, which will be produced and passed to the interpreter here.
Okay.
So this red
Your voice is breaking, Manoj.
box is the byte. This is a this bytecode will actually an interpreter will translates this into a mission executable once which Python works. In Python, can you hear me now? Clear?
It was little breaking. Yeah, tell me.
Okay. Please let me know if it gets worse. Okay.
Yeah, yeah, sure.
So we can uh, session. Okay. So Python actions paint window. So the first and one this interpret in Python in terms of EVM. It's called a Python virtual machine. And I mean, don't get yourself confused about this virtual machine kind of thing, we'll look into it in detail when we continue with a little more advanced section of this classes. Okay. So
Yeah.
just remember that this is also called as EVM, something called free time. Just try to go and see all these terms so that you can find some better explanation with in a detailed way. This is Python virtual machine. So this is how Python code actually works when you find the scene, and this compilation process will actually be something called a bytecode, something what you saw in this code editor,
Yes.
and further uh, 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 gets translated by an interpreter or is actually uh, mission dependent. They have a different interpreters for different platforms. It is actually easy and quite effective than developing different interpreters than developing different compilers. Because if we have like a language like C and C++, which have a different set of compilers for different platforms like Windows, Mac, and Linux. But here the compilers are actually same. And you might ask why we need two steps of translation here. This is for the portability purpose. Actually, it helps to transfer the code very easily and effectively uh, without considering the underlying platform. So this is so yeah, with this. Hello,
Manoj, your voice is actually getting break. Hello?
hello,
Yes, Manoj?
hello. Can you hear me?
Yes, Manoj.
Yeah, yeah, yeah.
I think the
It,
network
it
is
could
getting.
be the network is getting low. Could be the rainy weather. It seems. I don't know. Okay, so now you understand what is understood what actually happens in computer
Yes.
behind the scene. I mean, how actually computers instruction and what are the instructions and what are different types of languages and how language gets translated to a machine executable code. I mean, we talked about the two types of translation, and one is using a compilation process, and another one is using interpretation process. Can you recall this?
Yes, yes.
Hello?
Yes,
Yeah.
Manoj. I can hear you.
One is using compilation process, interpretation process. Okay. And some languages uses both. Python actually uses both compilation and interpreter
Interpretation
process.
also.
And one more thing, I just need to tell you that when you uh, when we discuss about compilers, compiler will translate uh,
Your voice is
from
breaking,
high
Manoj.
level, the only
Hello?
perform translate one high level, excuse me, codes from yeah. Yeah, can you hear me, Nancy?
Yes, Manoj. It's total disturbance actually.
Hello.
I think, hello? You able to hear me? Hello?
Training, something like hear me?
I can hear you, Manoj, but
Hello.
the voice is actually disturbing.
Yeah, but my network is actually in full range. I don't know what is the problem. So, how is the climate there at your place? Is it cloudy or rainy, anything like that?
It's raining heavily actually, but even for me, network is showing fully.
Even for me, actually, even here, the network is full. Because if there is any problem with network, it actually shows me with that, it notifies me, but it shows network is fine. Okay. So you can hear me now, right?
Yes, Manoj.
Okay. So do you have any doubts so far what we discussed today?
No, I'll also go through once.
Because
Anything
if
I
you
will
have any
actually ask
doubt is
you tomorrow.
something, uh, okay. Yeah, please go ahead. Hello?
Hello? Yes, Manoj.
Hello?
Hello? You able to hear me? Hello?
Mm. Nancy, let me just disconnect and reconnect the session. Looks like there is something problem with the network. Okay. Yeah. Hello.
Yes, Manoj.
Hello.
Yes, Manoj.
Can you hear me clearly now?
Yeah.
Yeah. Okay. Let me share the screen back. Yeah. So, so any doubts so far, Nancy? Just ask me
Uh,
whatever it is.
that's what Manoj, today's class, I'll just go through again. And in
Okay.
tomorrow's class, I will check. I'll let you know if I have any doubts. I'll just have a glance
Oh,
of it.
okay. So I actually thought of um, discussing another thing called the programming paradigms today, but we didn't have enough time. No problem. We'll do that tomorrow, and I'll
Yeah.
try to cover this as fast as possible. But if there is any need to go slow, I'll do that. No problem.
Yeah.
And we'll also install Python environment, and you can just some time between this next week. So
Okay.
you actually took the weekend batch, right?
Yes, Saturday, Sunday.
So you have only Saturday and Sunday classes, right?
Yes.
Okay. So we just install the environment to the code editor. So maybe from next week, you after looking into some concepts, you can actually try practicing with some code, I think. Okay. So
Okay.
do you want me to suggest something, or you want me to notify something in teaching process where I want to be a little bit more clear? Thing?
No, as of now, it's fine. It's fine.
Fine,
Hello?
okay. But I'm just telling you, if you feel anything that uh, yeah,
You're not audible,
if you
Manoj. Voice is not clear.
feel like I'm making things in a confusing way, not with any concepts, just hello.
Yes, Manoj, your voice is not audible, Manoj.
Yeah, I just stopped sharing my screen,
Yeah,
and
just tell.
let me just repeat what I told. Uh,
Yeah.
yeah, if you feel like I'm not clear with any concepts, or my lecture feels like anything confusing, or so anything, any discomfort in my teaching, you please feel free to come up with this, so with it, so that I can actually make corrections. Okay?
Sure, sure. Done.
Yeah. Okay.
Yeah.
Okay, Nancy. So that's all for today. I'll meet you tomorrow. So you can join at 5 o'clock tomorrow, right?
Yes, yes, sure.
Okay. So if there is anything, you just like today, you just inform to Amrita regarding.
Yeah, yeah, I'll do that. Yeah.
Okay. Yeah.
Thanks, Manoj.
Thank you, Nancy.
Yeah.
Have a great day.
Yeah, thank you. Bye.
Bye.